Can I start, sir?
Yes.
Hello, everyone, and welcome to today's session. I'm your host for today, Annie Grace from ECE Department at Shadan College of Engineering and Technology. It's an immense pleasure to introduce today's guest speaker, Dr. SHAIK SAIDULU, sir, who is professor in ECE Department, who has been awarded with doctorate in embedded systems from Sunrise University. He has been nurturing and guiding students from the past years, and he is our placement officer in Shadan College of Engineering and Technology. It is an honor to have Dr. Shaik Saidulu sir here today with us for today's session on design and development, prototyping. Yes, Saidulu sir, you can start the session, sir.
Thank you, ma'am. Welcome. Yeah, welcome to one and all. The respectable chairman, Dr. Muhammad Shalam Masloul Khan, sir, the chairman SCET, the respected principal, the Dr. MD Atikur Rahman, sir, the director, and my HOD, and IAC coordinator, giving me an opportunity to deliver a talk on phototype, process design, and development of the prototyping. Yeah, myself, I'm Dr. SHAIK SAIDULU, working as a professor and the TPO at Shadan College of Engineering and Technology, Hyderabad. Yeah, today my topic is on prototype, process design, and developing a design. Yeah, prototype. For okay, what is the agenda of this the particular meeting is that prototyping implementation process design, how to implement the prototypes and the process design. Yeah, prototyping and the construction. The first okay, we'll discuss about okay, what is a prototype and why we go for the prototype and different kinds of the prototyping. The first and foremost, we will discuss about the prototype, the importance of the prototype. Prototype is nothing but a which is a design which can be worked with the some principle and the major the major of the concept and the main concept okay we will be making to a smaller smaller uh, example of the model that is called as an prototype. uh, then why we go for the prototype? First of all, if you go for a direct of a design in a design and implementation, uh, a lot of complexity is going to be involved in the design and the production and the marketing and the fabrication and the marketing. Okay, these four things are involved in the in any design process. Suppose if you are not implementing a prototype, if you are going for a design, then the the design may work or may not work. We can't predict that. If the design is going to be a failure, once the product is released in the market, then the whole product has to be failed or has to be returned. Then a lot of expenses, a lot of the market, okay, name of this particular company is going to be loose. So that is the case. The prototype is the functionality, the basic of functionality. Okay, we will test with that. If you take any computer programming and a flowchart, the prototype is nothing but an algorithm and simulation results. If you are going to be a electronic designs, the prototype is nothing but a smaller simulation result. Okay, we can do this any simulations. If you are going for a mechanical, the mechanical the user products, the major products. Okay, we cannot design in a uh, yeah without prototype and the test. If you're going for a design, the whole money and the whole hard work and the design is going to be wasted. So that is the case, we will go for the prototype, right? Here the mechanical prototype, okay, we can take with the smaller events, and we yeah, we are going with a prototyping of a test. Why the prototype? Prototype is the prototype is the basic model example for the real-time design is we use and we design in this one different kinds of prototypes, where the low fidelity prototypes and high fidelity prototypes. There are two types of prototypes are available. The first we'll discuss about the low fidelity prototypes. What is a low fidelity prototype? The low fidelity prototype is nothing but a the prototype which is which is with the uh, the minor uh, yeah, devices, and okay, where the simulation results are not going to be achieved, means it is a model which we can make here. Then we cannot reach this with the accurate values, exact simulation values, like where in the high case of fidelity, where the simulation results and accurate values we can achieve with this. What is the prototyping? In other design fields, a prototype is a small scale model, a miniature car, a model of building. In interaction design, it can be a series of screen sketches, a PowerPoint slideshow, a video simulating use of a system, a lump of wood, example, handheld computer, cardboard, markups, a piece of software with a limited functionality, where all together, which are embedded in prototyping design. Why prototype? Evaluation, evaluation and feedback. Uh, yeah, how to evaluate the prototype? This prototype evaluation maybe this uh, in this one, the prototype is similar to the main product or not, so that we have to be see first, and the model is same or not, and the principles what we are using there and here are going to be the same or not, and realistic is it is going to be realistic of uh, the main design or not, so that we will see in this one. And communication among the team members, clarifies the uh, clarifies the many issues from the stakeholders, like uh, the company market and the users, what they are expecting, and what are the requirements, and the same requirements we are giving to the design team, and the design team uh, a photocopy we are taking and implementing with the implementing team and R&D as the same. We are going with the production product team and the marketing team. So this many inputs, stakeholder inputs, we are going to be concerned and a particular design. The communication among the team members, these discussions are made by the Scrum managers. Validation of design ideas. The second point is the validation of design ideas. In a design, what are the ideas? Is there ideas that are going to be implemented or not? Is it feasible to design or not? What are the concerns behind that? That we will be check out for the first, and choose between alternates. This particular the feasibility as okay not possible, then what is the alternate? So based on the we will change our designs, or we will propose multiple designs for the one of the application. Based on that, we have to be go and finalize or move with us any one particular. Why what a prototype? There are uh, technical issues, workflow, task designs, screen layouts, and information display, difficult, controversial, and critical areas. The technical issues. In case of the technical issues, then this particular prototype is existing or not. Okay, that we have to be check it. If it is the existing one, then how how it is deviated from the existing one. So that we can define over there, and the workflow and the workflow design and the task design. Each task of the design is going to be a very concerned one to go into the market. There we can design a workflow from scrap to the product. How much of the time is required for each of the uh, design, and each of the time, so that we are going to be concerned. Then screen layout, screen layouts and information display. In case of the uh, any design which we require the screen layouts, okay, that will be shareable, and information will be shared to uh, from scrap to the product for every node and access. Difficult where any difficulties or controversy or critical areas, then we will discuss with the team, and we will meet the particular meetings with the R&D, and we are going to be implement according to that their suggestions. Low fidelity prototyping does not look very much like the final product. It is somewhat of a deviation as compared with the final product as per our previous discussion. It is the type of the material may be a different. Suppose in hydraulic automations, the prototype we will implement with the plastic simple with the syringe, uh, the techniques. But wherein hydraulic automations, hydraulic the fluids are going to be used. Okay, these are going to be final implementation is very difficult. Okay, that is the case. Okay, we are go with the low fidelity prototyping. Wherein IC design, wherein the IC design, we cannot go with the low fidelity prototyping in case of electronics example, where the simulation results we have to be designed with the code, the particular code, and we are going with a simulation of the results. So thereafter, we are going for implementation. The one cost IC design is, for example, from 1 million. Then the 1 million ICs, the cost is also similar to that, means 1.5 million or 2 million. If the product is failure, then the the whole money of the 1 million is going to be wasted. In case of the prototype also, if prototype is failure, the 1 million money is going to be wasted. Examples of low fidelity prototyping are storyboards, sketches, index cards, or we are designed with the similar material products, so whatever it may be, that we are considered as a wizard of this one. And storyboard, originally from film, okay, easier to get an idea of the sun's snapshots of interface and a particular point at an interaction. Series of sketches shows how a user can perform a task using the device, often user with the scenarios. These are the examples of the storyboard automatically. Yeah. Prototyping, how you are going to be take the prototyping from this the original one to here, simulated interaction, high fidelity prototyping, where choice of the materials and the methods similar to the identical to the final product, which is almost the closer results in case of the simulations of this particular hardware design, in case of this IC design, in case of electronic design, in case of electrical design, in case of the computer design. All these are high fidelity prototyping, where we are going for a particular software with synthesis and the simulation. Then we will achieve the final product with the result. So thereafter, we going to implement the same system on hardware. Looks like the final system, where the simulation, the results are up to the theoretical results are 100%, then at least we will achieve the product with a 90% accuracy. The advantages and disadvantages of this low fidelity and high fidelity prototypes. If you are taking an low fidelity prototype, low low development cost, evaluate the multiple design concepts. So these are the advantages. Yeah. And if you go for the disadvantages, this particular one, low fidelity prototype, the limited error checking, and the navigation and flow limitations. So there is a no navigation and the limitations from the top to bottom approach or the bottom to top approach. There is a limited error checking. The error checking is very very optimized, because we are not going to move with any particular simulation here, and the material type of the material and main product and here also be different, then we can't expect a full test or full-fledged results. Yeah, high fidelity prototype. In case of the high fidelity prototype, full interactive. You can look into the field or the final product. Clarify defines the navigational schemes. Well, in this one, okay, we can expect the final product is going to be work or not, to be demonstrated or not, based on the simulation and the synthesis of the results, where we are using a high level of simulations of this particular one, product one, and clarify the okay, defines the navigational schemes from the top to bottom approach and the bottom to top approach. Okay, these two are the uh, advantages. If you're coming to the disadvantages, more expensive to develop here. The development cost is very very high. If the prototype is failure, the cost of this particular design is going to be wasted, and time consuming to build. Here we have to be implement high fidelity system with a very time consuming process. Developers are okay, reluctant to change something they have crafted for hours. Yes, okay, there is no feasibility to change in the design, or once it is going to be simulated and fix them. Then, yeah, these are the major disadvantages of high fidelity prototype system. Compromises in the prototype. All prototypes involve the compromises. Yes. Okay, you have to be accept, okay, because it is like a prototype. Somewhere we have to be the compromise, because in any design, suppose a big turbine design in prototype, okay, we will run with a simple motor, with a simple electrical equipment, where we are running with this the particular model in a with real time, a lot of power is required, a lot of noise is producing, a lot of sound is going to be produced, the lot of airflow is going to be come out from there. Aeronautic designs are required, sound optimization techniques are required, but as a concern in the prototype, okay, we are not taking into the consideration. All these things are going to be compromises, right? Compromises in low fidelity prototypes, like the device okay does not actually work. Means somewhere the okay device may work or may not work in case of this okay low fidelity prototypes. Compromises in high fidelity prototypes. Okay, where the simulation response is a uh, very high speed response. If you are giving the input, it is operating with a system speed or okay, system clock. The response where we get is a very high speed responses. Wherein this okay, real-time implementation, wherein the real-time implementation, these things are not going to be uh, work okay, properly. It has to be a the response it may be a very slow as compared with the simulation results and the timing. Wherein the simulation result, the motor run. The simple example of the motor on off and any electrical device on off is going to be possible within a milliseconds in case of the simulation. Where in case of the real time and the prototype of the design, the concern, it has to be take a lot of time to respond. So that is called transition on time, transition off time, and the response time, sketches and icon. Okay, these are okay. Once we design, once we sketch, okay, this may be a failure. Then this the particular thing is going to be a failure. And one more, the limited functionality availability. Here, the functionality is very limited. It has to be compromised in high fidelity prototypes. Two common types of okay, compromises here. Horizontal provide a wide range of functions built with the little detail. Okay, this is called horizontal the compromise, and one more is a vertical compromise, provide a lot of detail for only a few functions, and the other functions are going to be hide over there. Construction, your design implementation. It is nothing but a construction, the creation, manufacturing of the final system. So based on the experience and feedback was gathered from the prototypes, then okay, then uh, the product team can okay, go with this the production of this particular prototype. Development philosophy, where this the evaluatory prototyping involves okay, evaluating a prototype into a final product. Okay, throw away the prototyping, usually a stepping stone towards the final design. Prototyping is thrown away, and final system is built from sketches. Based on this is your development the philosophy, the product is going to be awesome. Quality. So the quality, although the prototypes have undergone extensive user evaluating the final product, still has to be subjected to okay, rigorous okay, quality testing for all the following: reliability, robustness, maintainability, integrity, portability, efficiency, and absence. Conceptual design. The transformation of user requirements need to be a conceptual model, stepwise requirement, interactive, iterative, and then iterate some or more considerations. It may be a we have to be okay, implement within a single step or multiple means okay, top to bottom approach. Somewhere we uh, yeah somewhere we can go with this uh, okay one step back or one step ahead. It is to depend upon the previous okay, result and the previous uh, the product output. Consideration of alternatives, prototyping and scenarios. And prototyping are the scenarios based on this. Then we go for the consideration of an alternatives, okay, even based on this, the work of this particular prototyping or the scenarios on the real times. The perspective was, okay, for a conceptual model, interaction mode, uh, metaphor, interaction, okay, paradigm. Yeah, running example. Shared calendar okay, is the corporate environment for employees to maintain the schedule and organize the meetings based on the end user requirement or the stakeholders requirement. Based on that, the every uh, node and every employee is going to be trying to implement their their time slots by their almanac. Yeah, interaction mode. How the user invokes actions, activities by the user, and the systems of the response based on this. How the actions are going to be interacting with the system. Okay, this is nothing but the actions. The activity based instructing, conversing, manipulating, and navigating, exploring, and browsing. This particular one. Object based, structured around real world objects, process oriented. Support a work process, example financial software, product orientation, develop products that users create, modify, and maintain. Example of Microsoft Excel, Word, and all. The particular time it has to be update any update from uh, the product to the vendor side. We have to be to follow the updates, and we can buy the licenses software and we can renew the software within a time. So these are this modify and the maintenance. Prototypes in the conceptual design, evaluation of emerging ideas, the user feedbacks and okay, feasibility we will take, the choice of the methods and materials we can go. Continuous prototyping, low fidelity prototypes earlier on, high fidelity prototypes later. We have the evaluation of the prototyping, early prototypings, and the gradually enhanced and augmented appearance functionally. Uh, yeah, I will. Anim madam,
Yes,
this
sir. Yes, sir.
particular product design and prototyping implementation has okay concluded. The one we discussed
Thank
with
you, sir.
this can how to okay why we go for a prototype, what are the different types of the prototypes, how we are going to be okay design a prototypes, and okay, what we expected the okay results in a prototype, and and how we implement in your design uh, the prototype in the real time of the product or the end user of the product. Thank you, madam.
Thank you, Dr. Saidulu, sir, for sharing your valuable thoughts and insights with us today. Have a good day, everyone. Thank you. Bye. Okay, sir. Stop this, sir. Recording.
Okay, madam. Done.
Okay, sir. Okay, sir. Bye.
Thank you, ma'am.
ఓకే సార్ బాయ్. అది మెయిల్ చేసేయండి సార్, జిప్ చేసి మెయిల్ చేయండి లేదా డ్రైవ్ లింక్ అంటే షేర్ చేయండి జ్యోతి కుమార్ సార్.
ఎండ్ మీటింగ్ ఫర్ ఆల్ కొట్టాలనా మేడం?
ఎండ్ మీటింగ్ ఫర్ ఆల్ కొట్టేస్తే అది కన్వర్ట్ అవుతుంది మీది,
ఓకే,
అప్పుడు వస్తుంది, ఓపెన్ అవుతుంది. ఓకే సార్.
థ్యాంక్ యూ.